This is another set of related rate problems that you've been assigned to do, and I want to support you in your learning and help you with the related rate problems. So I'm going to walk through these problems for you and with you, hopefully. Water runs into a conical tank. Notice I'm reading with my pencil, and I realize that I'm dealing with a cone. And the rate that water is flowing into the cone is 9 cubic feet per minute. That cubic feet is what tells me that I'm looking at the volume rate. I see the cubic. The tank stands point down, so when I draw my cone, I'm going to make sure it's point down. It has a height of 10 feet and a base radius of 5 feet. How fast is the water level rising? So it's fast water level, and that is going to be the height, dH dt. So that's my job, is to find dH dt. So I'm going to begin by drawing my conical tank. It is point down. They told me that I have a base radius of 5 feet. So this is the 5 feet and a height of 10 feet. So that's how tall the tank itself is. Now, water is flowing into the tank. So I'm just randomly putting water level right here. So water is flowing into that tank and it's rising. So the first thing I'm going to do is I'm going to write down the formula for the volume of a cone, because that's going to connect my variables. So I know I'm beginning with 1/3 pi r square h, and I know that dV dt is equal to 9. So that's what I've recorded into my box of knowledge. Now, they've asked me to find dH dt. Find dH dt. That's what I want to find when h is equal to 6 feet. So if I know dV dt and I'm trying to find dH dt, then the r is a problem. Because if I find the derivative of this formula, I will have to use the product rule. And when I find the derivative of r squared, I will introduce a dr dt into this problem. And I don't know dr dt. I don't have any way of calculating dr dt. So that would give me too many unknowns. So that right there tells me, since I don't want a dr dt in the problem, that tells me I need to get rid of this variable. Somehow I've got to replace this variable with something. And that's where this geometry idea comes in, that is often used on the AP test. It's a concept that you need to refamiliarize yourself with, and it's a pretty basic concept. I'm going to take this triangle that you see in the cone, and I'm going to pull it out down here. And so I'm not going to have it in the cone. And this big triangle that I'm drawing in black has a 5-foot radius, and it is 10 feet tall. You also notice that I can draw that little green triangle, just this part right here. Let me do that. I can make this green triangle that you see right here. All right, so I'm going to put that inside of my big triangle that I've already drawn. So this is going to be the little triangle right here and right here. So here's the geometry idea that you need to know and remember. There's a right angle here. There's a right angle down here. And the two triangles share this base angle down here. So from your old geometry days, you may or may not remember, but these two triangles are similar to each other, meaning that the big triangle is similar to the little triangle. Now, the significance of that is this. If two triangles are similar to each other, their corresponding sides are proportional. What does that mean? Well, we don't know the length of this radius, and we don't know the length of the height of the green triangle. However, we do know, because the two triangles are similar, that the corresponding side, so if I take a ratio or radius of 5 in the big triangle, compare it to a height of 10 in the big triangle, that's equal to the ratio of the green radius to the green height. That's what proportionality means. They're in the same ratio. Now, of course, I can reduce that 5 over 10 to be 1 over 2. And if I want to get r by itself, remember that was my goal. I want to get a replacement for r. I can multiply both sides by h, and that means that every radius is 1/2 the length of the height. Now you can write that as 1/2 h, or you can write that as h over 2. It's the same thing. So I'm going to go back up to my formula, which is back up here. I'm going to replace that r with the h over 2. Then I'm going to do the algebra. I'm not ready to do the derivative yet. I'm going to square the h. H squared times h will give me h cubed. 2 squared is 4, times 3 in the denominator is 12. So my cleaned up volume formula is pi over 12 h cubed. You could, if it's more helpful to you, you can write it as 1/12 pi h cubed. Some students find it easier to differentiate that for some reason. So now you're going to use the power and chain rule. So on the left-hand side, the derivative of v is dv dt. On the right-hand side, when you use the power rule, 3 times a 12th is a 4th. H squared dh dt, leave a chain behind. And then, of course, at that point, it's just the substitution of numbers. A few of these steps got left out, so I'll try to show you what happened. 6 squared is 36. 36 divided by 4 is 9. So you have 9 equal to 9 pi dh dt. I can divide both sides by 9 pi. And that leaves me with 1 over pi feet per minute. Oops, where did my little box go? That's okay. So when the water level is 6 feet deep, the water level in the tank is rising at a rate of 1 over pi feet per minute. And I know I said no slanty fraction bars, but I'm limited in my typing. Because dh dt is positive. So if you're writing, don't write slanty fraction bars. That's a bad thing. Okay, number 5 is a problem that you've seen before. We have a right triangle. We have the figure represents an observer, and the observer is standing at point A. Let me get a pen here. So the observer is standing right here. The observer is exactly 100 feet away from the balloon. And this 100 feet is a constant, meaning you can put it into the problem from the very, very, very beginning. That 100 feet is not changing. It's not variable. It goes in from the beginning. The balloon is rising, so the balloon is starting right here at point C, and the balloon is moving upwards, and this is the height of the balloon measured by y. So the balloon is rising at a rate. That's my dy dt, because if the height of the balloon is y, the rate of the balloon is dy dt, and that's 3 meters, in this case, per second. When y equal to 50 meters, find the rate of change in x. So that's saying find dx dt. So let's begin there. That's just going to be basic Pythagorean theorem. I can see that 100 squared plus y squared is equal to x squared. Classic Pythagorean theorem. So there is my Pythagorean theorem work. 100 squared, y squared, x squared. Take the derivative of 100 squared. That's a constant, so the derivative is 0. The derivative of y squared is 2y dy dt. The derivative of x squared is 2x dx dt. I can divide the 2's out on both sides to make my arithmetic smaller. I know that y is 50, so I know that. I know that dy dt is 3. I'm looking for dx dt. That means I'm going to need to find a value for x. So I'm going to go back to the Pythagorean theorem. Remember, we know that y is 50. So in the Pythagorean theorem, well, I'll just show you that real quick. I have 100 squared, which is the bottom leg, plus y squared, which is this leg right here, equal to x squared. So x is the square root, and y was 50, sorry. So x is equal to the square root of 100 squared plus 50 squared. The dx dt is not under the radical. And I'm leaving that exact until the very end. So 50 times 3 is 150, and I'm going to divide by that radical. And now, since I'm in the very last step, I'll use my calculator to change that to 1.341. Make sure that you definitely have 3 decimal places. It's absolutely required. It's meters per second dx dt. So when the balloon is 50 feet in the air, the distance between the observer and the balloon is increasing at a rate of 1.341 meters per second because dx dt is positive. For letter B, we are now finding the rate of change of area. So rate of change of area rate is dA dt of the right triangle. So I'm going to need an area formula, which is 1/2 base height. But in this case, the base is 50 and the height, I'm sorry, the base is 100. I already took a half of it. The base is 100 and the height is y. So my formula is going to be very easy in this problem. The area formula is going to be 50y. So 1/2 base height, 50y, as I just showed you. The derivative of a is dA dt. The derivative of 50y is 50 dy dt. I know dy dt is 3. 50 times 3 is 150. Look at the units. Meters square. Area squarea. Area requires square units. And I don't think I have a sentence written for this one, but basically the rate of change of area, dA dt, is 150 meters squared per second. So the area of the triangle is increasing when the balloon is 50 feet in the air. Now this last one is very important. I've seen it pop up on the AP test before. Let's change colors. Let's go with get my pen, come on back, to a blue. So for letter C, we are finding the rate of change of theta, which is d theta dt. Now over here, I'm going to erase some of this stuff. They've already told me what theta is. Theta is this angle right here. So since I have a right triangle, this is going to be sa, ka, to, I can use sine, I can use cosine, I can use tangent. It does not matter. However, I want to be smart, and when I set up my equation, I'm going to definitely use this 100. I don't really want to have 2 variables and 2 rates to deal with when I can just use the 100 as a constant. So I can either use, so if I look at my angle right here to be theta, I can do adjacent. I want to include the adjacent for sure. So adjacent over opposite would give me, or opposite over adjacent would give me tangent, or adjacent over hypotenuse would give me the cosine. Those are the 2 that I would choose from, and I don't remember what I did in this work, so let's just see. I decided to use tangent. Tangent theta. So tangent theta, coming back up to the triangle, is opposite. Come on, you can do it. Come on, go, 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 go. Is opposite y over adjacent 100. Now remember, again, some of you get really confused with the way this looks. This is tangent theta equal to 1 over 100 times y. The derivative of tangent theta is secant squared, don't forget d theta dt. The derivative of 1 over 100y is 1 over 100 dy dt. Remember, we already know that dy dt is 3. What I now need to figure out is what is secant squared of theta. So before I worry about secant squared, I'm going to ask myself, well, what is secant of theta? And then if I can get that, I can square it. I know that secant theta is 1 over cosine. I know that cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. That means I'm going to go back up to the triangle and find the length of the hypotenuse and the length of the adjacent side, which I already know the adjacent side is 100. The hypotenuse is x. Now remember, we found that earlier. It's right here. The length of the hypotenuse is the square root of 100 squared plus 50 squared. So hypotenuse is the square root of 100 squared plus 50 squared. Then, so I have secant. Now I'm going to square it because it's secant of theta squared. So that's going to take the radical off of that. So that's going to be 100 squared plus 50 squared over 100, which can be done, of course, with your calculator. So I don't worry about the fact that it's 50 square root 5. That part I don't care about you knowing how to simplify that radical. But when you simplify it, it becomes 5 over 4. So if you use your calculator, do 100 squared plus 50 squared over 100 and reduce it, you get 5 over 4 d theta dt. And remember that dy dt was 3. And 3 times 100 is 3 over 100. To get d theta dt by itself, I'm going to multiply both sides by the reciprocal. So I'm going to multiply by 4 over 5, 4 over 5. And that will give me, when I reduce, 3 over 125 radians per second. Spend some time with this problem. Spend some time figuring out the algebra, the trig, the arithmetic. The main thing is to go slow, and one of the keys for this trig problem is figuring out using your triangle. Notice I went directly back to the triangle to get all the information for secant. Remember that I found secant of theta first, then I squared it after I found what secant of theta is. Number 8, I'm not going to do in this video because we've done several problems like this before, and this answer is in your packet, and I don't want to really just do more time working that problem. You can ask me in class if you're struggling with it. Same thing with number 9. It's a circle. It's pretty basic. We've done this about 3 or 4 times now. However, I'll be glad to... Oh, no. I remember this one. Let me talk briefly about number 9. The kicker in number 9 is that they give us that the area rate is 3, look right here, square feet per minute. And I think the answer in your packet might be wrong because I think whoever did these answers, it wasn't me, didn't pay attention to the fact that the radius is 10 inches, not feet. So that's a problem. Right here, the area rate is in square feet, so we need to convert 10 inches into feet. So 10 inches is 10 inches out of 12 inches, because that's 1 foot, which reduces to be 5/6 of a foot. So that's where this number is coming from right here, and I think, if I remember correctly, maybe your packet answers may not have taken that into account, the person who did those answers. So that's 5/6 feet. The problem itself is really easy. The area of a circle, 2 pi r dr dt. Substitute 5/6, not the 10. and you get, so check yourself, the actual answer for this problem is 9/5 pi inches per minute. So easy problem, but the person who did the problem in the packet, unless I fixed it, forgot to account for the changing of the units. Doesn't really they don't really do that to you on the AP test. So just saying. Number 10, I actually want to do for you. A light is attached to the top of a 12-foot lamppost. So here I am reading with my pencil. The first thing I notice is I have a 12-foot lamppost. If a 6-foot man walks away from the lamppost at a rate of 5 feet per second, how fast is the length of his shadow increasing when he's 5 feet away? All right. So if I have a lamppost and the light is shining right here and it's casting a shadow, I have a man who's walking, we'll say this way, and that man is 6 feet tall. The light is shining in such a way that he cast a shadow on the ground. So this distance right here, this is his shadow. All right, so let's go back. A light is attached to, if a man walks away from the lamppost, so the man is, let's say he's starting, let's change colors again. Let's say the man starts right here, not standing on, but he starts right here and he starts walking in this direction. We don't know exactly where he is, so I'm going to call his distance away from the lamppost, that's going to be X. That segment right there, that's where the man's walking. And this black segment is the length of his shadow, and I don't know how long that is either, so I'm going to call that Y. All right, so if that's the case, so now the 12-foot lamppost doesn't change. The 6-foot tall man doesn't change. The lamppost is 12 feet. The 6-foot man is 6 feet tall. Question. So if I use these variables, how fast is the length of his shadow? So they want me to find dy dt, because the length of a shadow is y, so the rate of a shadow is dy dt, increasing when he is 5 feet away. So that's an x value when x equal 5 feet. And they said he's walking away from the lamppost at a rate of, so his rate of walking, the dx dt, is 5 feet per second. Okay, this goes back to the very beginning problem. It is a triangle inside of a triangle, so I'm going to review that real fast. We have another right angle, and we have another right angle, and we have a shared angle here. So the big triangle that I'm tracing right now is similar to the little triangle by the angle-angle postulate of similarity. So since the two triangles are similar, the corresponding sides are proportional. The corresponding sides are proportional. So let's take the 12-foot lamppost. Now you got to remember which triangle that's out of. That's out of the big one. So I got big 12-foot out of the big triangle compared to 6 feet out of the little triangle. So I'm doing a big side compared to a little side. And that is equal to, so there's the 12 in the big triangle. Now look right here. This whole length all the way across from here to here is the whole side of the big triangle. That's x plus y. The length of that whole side is x plus y. So in the big triangle, the base is x plus y. And in the little baby triangle, the base is just y. So big to little, big to little. Okay, so I have my triangle, excuse me, I have my equation that relates my variables. So I'm going to cross multiply, which gives me 12y equal to 6x plus 6y. I'm going to subtract 6y to the left, and that'll give me, I'll bring it up here, 6y equal to 6x. And that'll give me y equal to x, and that'll give me dy dt equal to dx dt. Dy dt, excuse me, dx dt was given to be 5. Therefore, the rate of change of his shadow is also 5 feet per second. And finally, the last problem. So a police cruiser approaching a right-angled intersection from the north. So the police cruiser is, in my triangle, is up here. It is approaching the intersection from the north. Is chasing a speeding car that has turned the corner, is now moving east. So the car is moving eastward in this direction right here, moving away from the intersection. When the cruiser is 0.6 miles north of the intersection, the car is 0.8 miles east. The police determined with radar that the distance between them, so the distance between them is this z, the hypotenuse of your triangle, between them, and the car is increasing at 20 miles per hour. So that is my dz dt. The distance between them is increasing, therefore a positive 20. If the cruiser is moving at 60 miles per hour, now this is important to pay attention to here. Remember, the distance from the cruiser to the intersection is decreasing, therefore dy dt is negative 60 miles per hour. At that instant, what is the speed of the car? So we're looking for dx dt. Okay, so we begin with our Pythagorean theorem. It's pretty classic. And x squared plus y squared equals z squared. Take the derivative on both sides and divide, and don't forget the chain rule, divide out the 2's. I know that the distance of the police cruiser is 0.6, so that's my y value. The distance of my getaway car is 0.8, and by the Pythagorean theorem, that leaves z to be 1. So I'm going to substitute the 0.8, the 0.6, and the 1. I know I'm looking for dx dt. I know the rate of the police cruiser is negative, and that negative is right there, negative 60 miles per hour. And I know that the rate of the distance between them is 20 miles per hour. So with my calculator, I can get dx dt by itself to be 70 miles per hour. I hope this helps you to get a better grasp on related rates.